Let me see if I can do this. All right. Oh, no. Oh. All right, we're live. All right, for this first one, based on the information that supposes that Dr. Eve applies a 30 Newton force is applied to the side of a 16 kilogram block. Right away, just based on this information, you should be able to go ahead and draw the block at 16 kilograms. You can ask questions. That's fine. Not like where do I get this headset because it's awesome. I got it from Mr. Bryce, but you can't know that. All right, so hopefully you got 156 newtons or negative, and you simply did that by taking the 16 kilograms and multiplying it times the acceleration of gravity. And it means since he's not falling, that the force pushing up from the floor is going to be 156 newtons. Okay, and it says there's a force applied of 30 newtons. Everybody good so far? All right. So we can answer just by doing this, and that's why this is important to do. Now I can just go through here and fill in my answers. So what is B? What's the answer to B? What's the weight of the block? Yeah, negative 156. Negative 156. Okay, what is the normal force on the block? Okay, it's a positive 156. 156. All right. Now, based on information, what is the coefficient of the kinetic friction? Now, it said the box is static, so should it be kinetic friction or is that a typo? If you look here, it says that it's a 16 kilogram box that is sitting on a table. Right, so should it have been 16 kilogram block? Should it be kinetic friction or static friction? Static, yeah, that's a typo right there. So that should have been a static friction. So what is the frictional force on the block? All right, a negative 45.47 newtons. Good. What is the force, the net force on the block? You got 0? Good. Why is it 0? Yeah, if we think about it here, some of you, I saw your answers, and you actually subtracted the two, so you came up with a frictional force of 15.5. If you had a negative 15.5 force, what you're actually saying is when I push the block, it actually is accelerating backwards and running over me. That might happen when you're pushing something out of the snow, but that's not a very good thing to have. So your net force here is actually going to be 0 newtons. And if you think about it in this way, right now all of us have a different mass, okay? Which gives us a different force of gravity on this floor. But everybody's net is 0 because we're standing still. Does this floor have a maximum weight that it can hold? Yeah. If I were to sit here and just pile up some of the heaviest materials in the world over and over again, in a certain spot I'll find a weak spot and it'll break through. Right? What's that? Let's do it. Yeah. No, it won't fall on guidance. We love guidance. So you have to remember that that's the way it's going to work. So what's the acceleration on the block from the net force? That as well should be 0 meters per second squared. And the best way to think about this, once again, is if we use some of the stuff we had from our lab, right? When I pull this guy in here, remember, this simply shows me once again, right? This is always balancing out. It has to be 0 because there's no movement in it. So what we see is when we calculate the kinetic friction, in that instance, it's showing us what's our maximum threshold that we have to achieve in order to move it. Like here, I have a maximum threshold, and once I exceed it, it was 325. And now I'm at 326, so I have a sum of forces of 1 Newton. Make sense? Everyone see that? I won't try and hide the questions in there like that, right? It's good if you apply the knowledge, but I'm going to call it out to you because you can't just go through a plug and jug. Okay? Try and understand what the numbers mean. Any questions on that one? All right. Good. I can stop recording.